We're going to put that to the side because we have to get you ready for the AP exam. So we're going to talk through all right, let's take a look at the next question. We're going on to the year of 2015. To increase business, owner is running a promotion in which the customer's bill can randomly be selected to receive a discount. When a customer's bill is printed, the program in the cash register will randomly determine whether the customer or not receives a discount on their bill. The program is written to generate a discount probability about 0.2%, probability of 0.2, so that is giving 20% of the bills a discount in the long run. However, the owner is concerned that the program has a mistake and that the results of the program are not generating the intended long-run proportion of 0.2. So the owner selected a random sample of bills, found only that 15% of them received discounts. Confidence interval for P was made, so it's running from 0.15 to plus or minus 0.6. So because of that, so they're going to ask you, consider that confidence interval. And does the confidence interval provide convincing statistical evidence that the program is not working? And the answer is no, because when you build the confidence interval from that, it can go all the way down to 0.09, or up to 0.21, and 0.20 falls within that confidence interval. So since it's a plausible value, we don't have any, we can't say it doesn't work, right? Part 2, part 2, does the confidence interval provide convincing statistical evidence that the program generates a probability of 0.2? Well, no, because anything inside the confidence, I mean, remember, confidence interval is, we are 95% confident that the confidence interval catches the true proportion. It can be anywhere from the bottom to the top. 0.2 happens to be one of those, but there are anything within that confidence interval is a plausible value. So this doesn't prove that 0.2 works. It just says that we can't not prove that it doesn't work. All right, now for the fun one. On part B, they ask you they're going to do a second random sample. They're going to go 4 times the size of the original sample. In the second sample, 15% also received the discount. Determine the margin of error based on the second sample of bills that would be used for this. Okay, so the p-value is the same. We can't change that. Z-value is the same. We can't change that. We don't know what n is. And so what I did here was, so here's my margin of error. So I've got the formula as n. Now, all we know is that in the new one, we've got 4 times n. So I just went 4 times n on the bottom. When I do that, the only thing that's different now between this one and this one is the fact I've got this 1/4, the square root of 1/4. So I pull that out. Notice that this part right here is the same as what we have up over here. So when I take the square root of 1/4, it's going to be 1/2. Now, you may remember that us talking about something when you're increasing the sample size, it's the square root of whatever the proportion difference is. Okay, or if you want to cut something in half, you have to go 2 to the 4th power larger than that. Regardless, we know that the new sample size is going to be half of whatever the new sample size, the margin of error is going to be cut in half from the old one. Since we know the old one is 0.06, the new one is going to be half of that. And so half of 0.06 is 0.03. So that's going to be our new margin of error. They then go on to ask, based on the margin of error in part B that was obtained for the second sample, what do you conclude about whether or not the program is working as intended? Justify your answer. So the new margin of error of 0.03 would create a confidence interval that runs from 0.12 up to 0.18. Because again, they said the sample, remember the proportion in the middle of the sample was 0.15. So since 0.20 is outside your confidence interval, that's convincing evidence that there's something wrong with the machine, because if it's truly going to be doing that, that 0.2 should be within the confidence interval. All right, talk to you soon. See you later.